Hello everyone. Today we're going to be talking about isomers of alkanes. And we defined alkanes previously as organic molecules or hydrocarbons that consist of only single bonds between the carbon atoms within the molecule. Isomers is just another sort of specification that we can put onto our organic molecules, and we'll define those in just a moment. But in order for us to understand what isomers are, we need to realize that not all alkanes or organic molecules are straight chains like we've seen so far. So we've seen molecules like this, right? We have 1, 2, 3, 4, 5, 6 carbons. So we would call this hexane. However, we here have 1, 2, 3, 4, 5, 6 carbons as well, right? And therefore we'd have the same number of hydrogens too, but you'll see that these two molecules are different, right? One is a straight chain, one has a sort of branch at the end that we see right here. So the formula for this molecule is C6H14, which is the same formula we have for this one, right? They're both the exact same molecule when it comes to the formula that represents them. However, geometrically, they're not the same molecule. So we need to have different names in order to be able to differentiate between the two. These are known as isomers. So an isomer is a molecule that has the same molecular formula as a different molecule. However, the atoms are arranged in a different order, right? So you'll see here and here, right, again, the exact same number, the exact same type of atoms, carbon and hydrogen. However, there's a difference in the way that they're bonded together. So these two would be considered isomers of each other. And because they are different, and different isomers can have different molecular properties and different uses to us, we need to be able to tell the difference with the name, right? I need to be able to communicate which one of these I'm talking about when I'm talking about what type of molecule it is. So, functional groups are the part of the molecule that comes off of the main carbon backbone here, right? We have 1, 2, 3, 4, 5, 6, 7, 8 main carbons in the longest possible chain. That's what we call the carbon backbone. And then here we have one carbon group coming off, right? This would be our functional group for this molecule. So when it comes to naming functional groups, we just add the YL suffix to the numbering prefixes that we talked about earlier, right? So we have methyl for one, right? Or meth means one, but a functional group that only has one carbon would be a methyl or methyl functional group. So this would be a methyl group here. If we had two carbons, if you recall, eth was our prefix for two, it would be an ethyl group. 3 prop, it would be a propyl group, right? So we just add this YL at the end of the prefix that we use for the number of carbons. So one carbon, again, is a methyl group, and how we name them, 2 carbons is an ethyl group. How we would name this here, right, is we take the longest possible chain and then we tack on the methyl group here. I'll show you the steps in just a moment. So naming alkanes with functional groups, I like to give you the steps to follow, so here are the steps. We find the longest carbon chain, and this is the base name of the molecule. So let me move myself. If you look at this molecule, right, the longest possible continuous chain would be 1, 2, 3, 4, 5, 6, 7, 8 carbons. Our prefix for 8 is oct. This is an alkane, so it's only single bonds, so octane would be our base name of this molecule here. Then we identify any functional groups and number the carbons to have the functional group on the lowest numbered carbon. So again, the functional group is this methyl group right here. Again, it's methyl because there's one carbon in the functional group. Then we have to number the carbons in our chain to make it so that the methyl group is on the smallest possible number. So if you were going from left to right, this methyl group would be, this is carbon 1, 2, 3, 4, 5, 6, 7, 8. So then this methyl group would be on carbon 3. The other option that we have is to make it so that we start numbering from the right side. This would be carbon 1, 2, 3, 4, 5, 6. And in that case, the methyl group is on carbon 6. But again, we want to number the carbons so that we have the functional group on the lowest possible option. So in that case, we would number from the left to the right because we want the methyl group to be on carbon 3 rather than carbon 6. So then we name as the number of the carbon the group is on. So in that case, this would be 3. I'd put a 3 here, hyphen, the group name, so it'd be 3 hyphen, the group name is a methyl group, so 3 hyphen methyl, then the base molecule, which we agreed was, I forgot, 1, 2, 3, 4, 5, 6, 7, 8, octane, right? So it'd be 3 hyphen methyl octane would be the name of this molecule here. So if there are multiple functional groups, we write them in alphabetical order. So if we have a methyl group here and then say an ethyl group here, we'd write 5-ethyl, 3-methyl decane, right? So if you have E that comes before M, so you put the ethyl groups before the methyl groups in the name. And then if there are multiple of the same functional group, then we would put di or tri as prefixes for that functional group there. So say we had a pentane molecule with 2 methyl groups, we'd write 2, 3 hyphen dimethyl, showing that we have 2 methyl groups coming off of carbons 2 and 3 of our main pentane molecule here. So these are a lot of rules, right? A lot of new words. I'm going to go through plenty of examples in just a moment, but these are the rules that we need to follow in order to come up with the correct names. So I have, these are 8 different molecules. I'm going to go through A, B, and D here and show you how it's done. In the slides, you'll see that there are, or I'll go through and have the answers at the bottom after I go through A, B, and D. So if you want to try it out before and then see your answers, feel free to do so. So here's A. So again, the first thing I do is I number my carbons, right? I find the longest possible chain, and the longest chain on this molecule is from the left to the right, right? I have 1, 2, 3, 4, 5 carbons. There's no possible route I can take that has more than 5 carbons from one point to another. So this would be a pentane as our base molecule here. Okay, now for the numbering, you have to think, does it matter if I go from left to right, if this is carbon 1 or if this is carbon 1? And in this case, particularly, it doesn't, right? Because if I go 1, 2, 3, 4, 5, my groups are going to be on carbon 2 and carbon 4. And if I go 1, 2, 3, 4, 5, they would also be on carbon 2 and carbon 4. So in this case, it doesn't matter which way I start from. However, again, sometimes it will, like in the next example. So on carbons 2 and carbons 4, both of my functional groups are only 1 carbon coming off. So again, I call those methyl groups. Meth meaning 1, and then ol meaning it's a functional group at the end. So I have 2 methyl groups. They are coming off of carbons 2 and carbon number 4. So now I know all the information I need. In order to name the molecule, the first thing I do is put the numbers. So I put 2, 4, hyphen. I have 2 methyl groups, so I put dimethyl. Di meaning 2, methyl meaning 1 carbon groups, and then the base molecule name, which in this case is pentane, because I have 5 carbons in my longest chain. So my final answer looks like this. I have 2, 4 dimethyl pentane. And so when you look at this name, and we'll do some of these reverse examples in a moment, pentane means my longest chain is 5. Dimethyl means I have 2 methyl groups coming off of it. And then it is on carbons number 2 and carbons number 4 that these methyl groups are coming off. All right, so that's A. Here we have example B, which is similar, but with 1 more carbon there. Okay, so, oops. Get on the right one. There we go. So again, the first thing we do is look for the longest possible carbon chain, right? So to do that, the longest chain we have is 1, 2, 3, 4, 5, 6, right? That's our longest chain. It would be a hexane, right? Hex meaning 6. So hexane is our base carbon backbone here. And then the numbering, right? Doesn't matter if we go from left to right or right to left. So in the last example, it did not, because it would have been on 2 and 4 regardless of which side you went. However, in this case, we have to number from left to right, because if we go 1, 2, 3, 4, 5, 6, then our groups, our functional groups, are on carbons 2 and 4, which are lower than if we went the other way. If we went 1, 2, 3, 4, 5, 6, then our functional groups would be on 3 and 5, which are higher numbers, which we do not want. So in this case, you do have to number from left to right in order to get the correct name. So hexane is our base carbon name, again, because we have 6 carbons in a row in the longest possible chain. We have 2 functional groups coming off of carbons 2 and 4 here. And since there are only 1 carbon in each functional group, those are methyl groups. So to name our molecule, we do 2, 4 hyphen dimethyl, because we have 2 of our methyl functional groups here. So di means 2, methyl's the functional group. And then our base molecule name, which is hexane, because we have 1, 2, 3, 4, 5, 6 carbon atoms in a row in our longest carbon backbone here. So 2,4-dimethylhexane would be our name here. Okay, one last example. Here we have a slightly more complex molecule, right? And so with these, it's really important to find the longest carbon chain. This is going to be your first example, or the first thing that you do. So the longest chain, like I just pointed at, is 5 carbons in a row. So pentane would be our longest carbon chain here. However, if we start from left and go right, our first functional group would be on carbon 1, 2, 3. If we start this direction, it would be on carbon 1, 2. So again, we want our functional groups to be on the lowest possible numbers, meaning we would start counting from right to left when we're numbering our carbons here. So pentane is our longest carbon backbone. So we have a 1 carbon functional group coming off of carbon 2 here. That's a methyl group. And then coming off of carbon 3, we have a 2 carbon functional group. So that's an ethyl group. So we would write 3-ethyl. Remember, we put ethyl before methyl because we've ordered them in alphabetical order, and E comes before M. So 3-ethyl, 2-methyl, and then our longest functional group, which is pentane. So this would be our name for this molecule. 3-ethyl, 2-methyl pentane, meaning that we have a 5-carbon chain with a 1-carbon group coming off of carbon number 2 and a 2-carbon group coming off of carbon number 3. So here are the answers to all of these. If you want some additional practice naming, this is a great way to do it. You can come back and check your answers. So now we're going to take some time to go the other way. I'm going to give you the name and then show you how to draw the alkanes. So we're going to draw 3-ethyl heptane, 2,2-dimethyl-butane, and 4-ethyl 2,3-dimethyl nonane. Okay, so for 3-ethyl heptane, the first thing I'm going to do is draw out the longest carbon chain, right? So hept means 7, meaning our longest chain is going to have 7 carbons. So I'm going to draw out all 7 carbons here to make out the longest possible chain. If you feel confident doing the shorthand, you're welcome to. I'm just showing you all of it here. So then I see that I have my functional group, an ethyl group, meaning 2 carbons, coming off of carbon number 3. So I go 1, 2, 3, and then add a 2-carbon functional group to it. And then I just fill in all the hydrogens. And remember, each carbon needs to have 4 total bonds. So you count the number of carbon bonds it has, and then fill up the rest with hydrogens. Okay, so you'll notice this carbon here, right? It has 3 carbon bonds, so it only has 1 hydrogen. That's something to keep in mind. And our molecular formula would be C9H20 because we have 9 carbons. We have 7 from the heptane chain, 2 additional from the functional groups. Then you can just plug it into that CnH2n plus 2 formula we talked about to get our molecular formula there. Second example is 2,2-dimethyl butane. So again, the first thing that I would do, and the first thing I do here is, not that one. First thing I do here is draw out the main chain. So the main chain is butane. Butane means 4, so I draw out a 4-carbon chain to get started. And then I look at my functional groups. Dimethyl, di means 2, meth means 1 carbon, so I have 2 1-carbon functional groups that are both coming off of carbon 2. So I draw out my 4-carbon chain, then I put 2 1-carbon functional groups coming off of carbon number 2 here. Then I just fill in all the hydrogens that I need. And this is 2,2-dimethylbutane because I have 2 methyl groups coming off of carbon number 2 of my butane chain. And again, you can find out the molecular formula using the equation or by counting each individual atom. Last example, I have 4-ethyl 2,3-dimethyl nonane. So this is a long one, sounds really complicated, but it's actually not that hard if you take it step by step. So again, nonane means I have my base carbon chain of 9 carbons. So I draw out my 9-carbon chain. Then I start looking at my functional groups. I have an ethyl group, which means 2 carbons, and I have 2 methyl groups, which means that each one is 1 carbon. So my ethyl group is coming off of carbon 4, so I add 2 carbons there. And then I have a methyl group coming off of carbon 2 and off of carbon 3. You'll notice how the one in the middle I put facing up. For alkanes, it doesn't matter which way, I just put it up there so it saves more space. It's not as crowded since the 2 next to it are pointed down. Then all you have to do is draw in the hydrogens like we've been doing. Again, make sure that each carbon is 4 bonds. Oops. So that would be what it looked like, right? We have our longest chain, our nonane chain, a methyl group coming off of carbon 2 and 3, then an ethyl group, meaning 2 carbons coming off of carbon 4. And in this one, I actually took the time to draw out the shorthand as well. We'll talk through that in a second. There you go. So you'll see the longest chain here is 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons, right? Just like our 9 carbon chain here. Then we have a 1 carbon group or a methyl group coming off of carbon number 1, 2, and another one coming off of carbon 3. Then carbon 4 has a 1, 2 carbon group coming off. This is an ethyl group, just like we see here. So again, this is just a shorthand way of drawing this out. They both represent the same thing to chemistry students who know what they're looking for. So both of these would be named 4-ethyl-2,3-dimethyl-nonane would be the name of these molecules. And so that's it. In the there's a great video on organic compounds in Crash Course, which I've linked here. You can go onto the Google Slides presentation and click it and watch it if you'd like. I'd recommend it, but I won't be showing it right now. Otherwise, now you know what you need to know.